welcome to my presentation. My name is Kaitlyn Handelman, and I will be talking to you about a little pet project of mine called LOMIC, the low Earth, low orbit mining ion cannon. So we'll start off with introductions, and then we will go over the basis of this, which is NOS3, and we'll learn about NOS3 and LOMIC. And finally, I will show you how to make your own spacecraft because it is so fun and you should all be doing it. All right, so who the hell am I? My name is Kaitlyn Handelman. And I swear, this is totally relevant to the talk, but I started off my career in kindergarten and I went over to NASA for cybersecurity as on the blue team. And then eventually I got scooped up by Amazon to be on the red team. And now I'm back sort of on like the purple team, where my main job is to secure the Kuiper space satellite system. So if you don't know, Amazon is putting up a satellite constellation, which will deliver high-speed internet connectivity, not only to the internet, like if you're a customer, you get an ISP, but if you are building IoT devices, cars, airplanes, you can have a dish on your product that goes straight into AWS. It is super cool. However, with that said, I have to give the standard statement, right? This is my personal project. LOMIC is my personal project. All views and statements are my own. So when I say something super offensive, that is me. That is not my employer. My employer does not know what I'm talking about today. And I do not speak for my employer. So everyone should be making that disclaimer. So how did I go from a kindergarten teacher to a space pirate? Because I was, hacking satellites, and before that I was teaching kids. Well, there's a college I was going to, and at the college, how do I say this? So at the college, there was there is, I should say, a cybersecurity department, and they had the coolest looking classes, which was exploit development, run by Sam Bound. He is awesome. Yes, thank you. Sam Bound is. Raise your hand if you know Sam. Yeah, we have a few people. Sam is awesome. So anyway, so I was at City College and I was studying violence intervention for kids. And that's the thing about being a teacher. You don't realize this going to school, but as the teacher in the classroom, you realize which kids are going through what stuff. And I go into the classroom and I'm like, I can't handle this. This is so, draining. I got to train myself up. But of course, I needed some levity. So I'm like, yeah, let's hack computers. So in that process, I joined something called CCDC, which is the Collegiate Cyber Defense Competition. And I did pretty well. Our team won. And afterwards, NASA was like, yeah, we want to give you a job. And I was like, wait, NASA wants to give me a job? Bye, kids. and there are many wonderful people along the way that got me to where I am. And as I was writing this, I was thinking about all the people, and I mentioned Sam Bound, but there's so many people, and I'm just thankful to all of them. I just wanted to throw that out. So now that I'm a full-time space pirate, I still volunteer to give back to CCDC. So this is an image of me at the Western Regional Collegiate Cyber Defense Competition at the regional. So what happens is the students defend their systems against me, and my colleague there in the red shirt is holding up an antenna, and we are going after some wireless devices. So what exactly is CCDC? Well, the students act like they are a blue team going into a crisis situation. The red team attacks the blue team. So the blue team are the students. The red team are industry professionals who go in and really try to make their lives as difficult as possible. And the ops team are the ones that design the environment that the blue teams have to defend. So they're defending a whole network against a whole bunch of industry red teamers. And the ops team goal is to design hardware that is realistic and networked that students may encounter in the real world. And one day I was like, you know what? I would like to try being on the ops team for once and seeing what I can do for the students. So I came up with this great idea that we should be giving all the students, like every college kids need to have this system to defend. A fully simulated piece of highly dangerous orbiting equipment running a full stack of core flight system, if you know what that is, it's what's running on a whole bunch of satellites without any security in place, no encryption, nothing. We're going to give the students a 900-page manual, and it's all commanded from a single unpatched Windows 10 box the developers pirate their games on. And students come to me and they're like, why are you developing these boxes? We wouldn't see anything like this in the real world. No, this is exactly what you see in the real world. This is what our space program is. I'm sorry. So here's a screenshot of the Windows 10 desktop that controls the dangerous satellite, and you see there's Among Us. They're playing video games. It's great. And here's an early screenshot. So yeah, enter NOS3. So what is NOS3? So NOS3 is something built by NASA. It's software. And they did most of the work for me because I was like, I need to get a simulated satellite that the students have to defend. I don't have time to build something like that from scratch. So thankfully NASA did. So thank you, NASA. Taxpayer money at work. I love it. So NASA operational simulator for small satellites, NOS3. So most of the credit for this talk really should go to NASA. Like I did a little bit of like editing here and there, but the vast majority of code that went into the simulation is all due to NASA. So big thanks to NASA. And essentially, NOS3 is a CubeSat simulator. So like if you are putting up a CubeSat, you need to do a whole bunch of stuff to keep it up in the air and functional. Take, for example, the detumbler sequence. That is hard. That is really hard to detumble a satellite, especially when some of the equipment starts to fail. As far as I can tell, the best way to do that is to use eigenvectors on the ground and somehow make sure you get it pointed in the right direction and, pray that the equipment actually works. So it emulates a full stack of hardware and software. And when I say full stack, I mean it emulates the hardware down to like you have UART ports, you have SPI interfaces talking to each other, you have Ethernet talking to each other, and then it on top of that runs core flight system, which is I'm not going to say operating system, but it kind of is an operating system that's very similar to ArduPilot, if you've ever used that, if you do drones, that runs on a whole bunch of space hardware. So this is fully simulated, CubeSats in space for serious people who are doing serious things. Obviously, we're not going to do anything serious with it, but that's what it is. Supposed to be, anyway. And that's what it looks like. And so this is a mess, and we're going to get into this. When you go to NASA's website and you download NOS3, you can, get the source code, compile it, whatever. But they know it is such a mess that they will give you a VM to run. And this is the VM running, and it is just a whole bunch of stuff going on. So enter LOMIC, right? So the low orbit mining ion cannon. So here's the scenario that we came up with for CCDC. The students are brought in because their company, which is doing lunar mining, is getting hacked by the red team. And part of this network is orbital mining equipment with a freaking laser beam that can blow up entire cities orbiting the Earth. So almost nothing is secured, as is the usual case. So there's no encryption, default and weak passwords, and there's no firewall rules. Red team goes in. And so just so people know, I am very proud. One of the things that Red Team has done over the past few years, when we get into the environment, we don't know what's there. We can get all the students' passwords in 15 seconds. I am super proud of that. So once we get the students' passwords, we get in, we start planting malware, we get over their systems, and they have to kick us out. And one of the things that Red Team can score points by is by either deorbiting the satellites or firing that freaking laser beam, which would be awesome. Pew pew. So yes, live demo. So I wasn't sure if I should wait until the end to show you, but I think it makes sense. So you see what happens when LOMIC starts. And the demo gods will not be nice. If you watch me before the presentation, I had to try 3 times to get this to start correctly. But here we go. So we type in make igniter. Is it running? Yes. We type make igniter, and I can speed this up. And then you run launch. It's going to create some ground networks. It's going to run this for a while. And oh, I'm so glad I can fast forward. Here we go. Windows are popping up. There we go. Oops, a little too far. More windows, more windows. There we go. And then we start seeing the satellite in space, and it is orbiting Earth. And the students can fully command and control this satellite using their ground station software. And like I said, each component in the virtual satellites is a real component that is running, real flight software. And of course, the students had no idea what they were getting into. They didn't know they were doing any flight stuff, and they have a 900-page manual about 20 red teamers trying to hack into this thing, and they have to secure it. So anyway, that was a lot of fun. Let's go back to the presentation. So how does this all work? So the main part of NOS 3 are what's called components, as you might guess. And if any of you have built CubeSats or worked on satellites before, you know they're all about components. And so one component might be a GPS receiver. Another component might be the IMU, or inertial measurement unit, which can tell if it's accelerating or decelerating. Do I see some students in here from CCDC? Oh, yes, over there. Perfect. So there are some students in here too watching, so that's awesome. And so there's 3 parts to each component. You have the simulator component, which does the hardware, right? So, and it's very light hardware simulation. So you're not debugging circuits, you're not looking at electron flow or RF or anything like that. You're just saying, if you get something from this port from UART72 or whatever, do this with it, send it here, that kind of stuff. Very high level, but it's written in C++. You have the flight software, which is Core Flight System. Core Flight System runs on everything, including real-time operating systems. So it is all C. And then you have the ground control definition files. These are not code per se, but they define what packets come and go from the satellite. So of course, if you have a satellite, you have telemetry coming from the satellite, and you have commands from the ground going to the satellite. And you need to define what are in those packets in the ground station software. And there's also another category called support, but support is just things you would reuse across different parts of the component. So think, once again, if you are using a UART port, you might want it defined as port 27 and not have to redefine it in 2 different places. And so this is what the folder looks like for a component. This is a sample component. So when you download NOS 3, it gives you a whole bunch of components to start working with. And this is the folder for the sample do nothing component. And you can see here, there's the folders for the flight software, the ground software, the simulation, and support. And if you go into the flight software, you see it's just like any other C type software. So the way Core Flight System works is essentially you compile a bunch of shared objects, and then Core Flight System will load them in to the system essentially. And so yeah, you see the core flight system stuff all in C and H header files, and the simulation stuff is all in C++. And we have a whole bunch of text files, which are just basic configuration files for the ground software. And so the other big components, you have the components themselves, but you also have 2 pieces of supporting software to make this all happen. The first one is Cosmos. And I bet a lot of you out there have seen this before, but essentially what it is it's a very famous open source ground control software. So if you're running some sort of TTNC, so that's telemetry tracking and control, you can run this off open source software. I do not know why, if you have the money to put up a satellite, you would want to use open source software for something like this, but I'm glad it's there. I'm to the bottom of my heart. I love this. And so you can use Cosmos to send the commands to the satellite, which essentially just uses a TCP port to send the raw CCS DS packets, but we'll get into that in a second. And so this is what the Cosmos looks like. There is a web version of Cosmos, that's version 5. What comes with NOS 3 is the 4.5 version of Cosmos, so it's not the nice web interface. But as you can see here, we have the GPS up. So we're looking at the GPS telemetry here, and you can see that we have the ECEF, X, Y, and Zs. So if you've never worked with GPS before, GPS uh, calculates your position using Earth center, Earth fixed coordinates. And of course, if you're flying in space, you really don't care about your latitude and longitude. You just want to know sort of where you are, X, Y, and Z. And here's the big one. So when you start it up, you get this really nice screen. You get the 3D graphics. And this is another NASA product. And by the way, Cosmos is not NASA. That's Ball Aerospace. 42 is NASA. 42, life, the universe, everything. It's and no, that's why they named it 42. It's everything. It's essentially a solar system simulator, but it's for spacecraft. So if you want to test spacecraft, make sure that you can get it to where it needs to go and orient it the right way. You can load the spacecraft into 42. This is what NASA does. They load it into 42, run their simulations. It does, end body, gravitational simulation, all that kind of fun stuff. And then you can tell if your spacecraft is messed up or if you're going to have a good day. And yeah, so it models the entire solar system. So we can have the satellite, you can see the satellite, the virtual satellite in space. And by the way, I used a modified version of Hubble because it was the closest thing to a ion cannon I could find. That was free. And there's a few other things too. If you look in NOS, there's a config directory, like a standard config directory, which you'll spend a lot of time in if you're making your own stuff, as well as a scripts directory, which is all the glue that holds everything together, and that's Python and Bash. And yeah, if I haven't made it clear already, this thing is a pile of garbage and difficult to work with, a complete nightmare. So you have dozens of independent processes, all requiring like containers. So you have Docker running, and you have like 24 Docker containers all communicating with each other, all running different components of the satellite. And if one fails, the entire thing fails. Oh my God, it's terrible. Oh, and forget about debugging. Like, have you ever tried connecting a just random debugger to a shared object file running in a Docker container? Like, yeah, no thanks. Okay, so you have config files. You have to know how they're structured. You have code in Python, C++, C, and you have, of course, Bash scripts that all have to work together. So I hope you know every language. If you make a change, you should probably clean and recompile everything because everything breaks all the time. It's difficult to develop for. I mentioned that, so you can't get a debugger easily, and it crashes. And I mean, it crashes a lot. It doesn't matter that it's like LOMIC or if it's NOS 3. It just crashes randomly. It's the weirdest thing. Just setting up for this presentation, it took me 3 tries to get it to start up correctly. I didn't change anything between the different attempts. It just the third time, just it worked. Okay, I'm cool with that. So let's talk about customizing NOS 3 so you too can make your own custom satellite. So the first thing you'll probably want to do is customize the spacecraft model. And thankfully, this is probably the easiest thing to do. So there's a config file in the config directory called scnos3. And you can change that to another object file that you will have exported from Blender. And so here is the modified Hubble. So you see there's no lid or anything. So the real Hubble has essentially like a lid that comes down to protect it from the sun. I took that off. I added some extra thrusters because you can't have too many thrusters. And I was like, okay, there's our ion cannon. Cool. You also need to use Wings 3D to generate the textures for it. But you do that, you're done. Cool. And one of the things that you will find is that if you're developing a simulated piece of hardware, the software needs to know where things are on the spacecraft. So I have a whole bunch of thrusters because for whatever reason, the reaction wheels would not work. So I was like, well, we don't need reaction wheels. I can throw on a bunch of thrusters. We can use those instead. So I added a bunch of thrusters, and those coordinates are just where they would be on the model. And then you set the orbital parameters. And if you are familiar with two-line elements, this will look very familiar to you. You set the periapsis, the apoapsis, the true anomaly, and all the things that you would find in a normal TLE file, just sort of spread downward a little bit. I also have another option that I haven't played around with too much, but you can create a vector. So you can say my spacecraft is at this position going this, speed. You can do that as well. I find it easier to just copy someone else's TLE and put that in. So if you go to spacetrack.org, you can just download a TLE for a spacecraft you like. I think I took the ISS and just plugged that in to the orbital parameters, and I got my cannon. And if you want to allow the spacecraft to change orbit, you can set the orbit parameters in the config files. So that was another thing too, because I like Kerbal Space Program. We should all like Kerbal Space Program. Raise your hand if you like Kerbal Space Program. Okay, every hand should go up. Okay, awesome. I like Kerbal Space Program. I wanted to give the students a freaking ion cannon that they could pilot around the solar system if they wanted to. Unlimited fuel, do whatever you want. So you have to turn off fixed orbits. Now, a funny thing happens when you turn off fixed orbits. Floating point errors happen. So it turns out the solar system is big. If the students turn on the thrusters for too long, the satellite will start jumping around here and there, and really wonderful bugs crop up. But it has to happen. We have to let the students pilot that spacecraft. And so now you have the configuration you want for your spacecraft. You know what you want it to look like. Now you create a component. So thankfully, and if you see here, so NOS3 comes with all these generic components. So you have, generic power systems, EPS. You have generic magnetometers, generic radio equipment, reaction wheels, star trackers. You can just copy one of those, make a few edits, and you can have your custom component. And that's essentially what I did. So that's why I said I don't deserve much credit. I spent weeks on this, but like NASA deserves most of the credit. They did most of the work. And you copy one of those, you edit it, and there you go. You have yourself a mining cannon that has enough fuel and can pilot itself to geostationary orbit. So that is awesome. So lessons learned. So there were a few lessons learned from this project. This was way too complicated for CCDC. I love going overboard, but even for me, this was way too overboard. A lot of the students didn't even realize they had this software running, and even if they did, it was crashing all the time and all this stuff. So it broke way too easily. There were so many components that rely on each other that one breaks, they all break. And NOS3 is designed really for short-term simulation. So if you have a CubeSat, you want to make sure that you can communicate to it at a certain time. That's what it's designed for. It is not designed to be running for 8 hours straight during a competition, simulating whatever the red team does to this satellite. And here is all the Docker containers running. I can't even list them all because there are way too many. Uh, um, and so you can imagine what a headache this is, having everything work together. And if one thing, like I said, goes wrong, oh my God, where do you even look? Also, CCSDS. So CCSDS, which is the standard messaging system between Earth and low Earth orbiting spacecraft, it's a type of packet, has a design flaw, I noticed. So if you look at the way NOS3 is designed, you'll find that the commanding IDs roughly correlate to the telemetry IDs. So normally, if you are working with like a CubeSat, something that's not like, military, they oftentimes do not encrypt the telemetry. And you don't want to, actually, because the less things that can go wrong on your spacecraft, the better. So you can read that telemetry. However, because engineers like to be methodical and they like to be organized, oftentimes the telemetry IDs at the top of the CCSDS packets are one-to-one with the commanding IDs. So I have an example here. This is, I think, for the thrusters. The telemetry packet that comes down has an ID of, what is that? No, that's command. Yes, that has the ID of 08EB. And the commanding CCSDS packet to turn on the thrusters has the ID of 18EB. So it's just one digit. They just switched a 0 to a 1. That's all they did. And that's for every component I've seen in NOS3. And so I imagine this is very common in a lot of spacecraft, especially student-built spacecraft, where they're not thinking about this. So that is something to look out for if you're doing real security research on satellites. If you can get the telemetry, there is a good chance that you can figure out how to at least begin to send commands to the satellite. And of course, the TTNC. So the TTNC stands for Telemetry, Tracking, and Control. This is what that workstation was. Remember, I said we're going to make this really insecure workstation, and the red team is going to get on it, and that's what they did. Red team is not going to spend a bunch of time creating a complicated piece of software to send commands directly through the network, from their machines into the simulation. No, you just get on the desktop and you send your commands through Cosmos. And in the real world, that's what happens. They go through the TTNC. So if you are doing any sort of space security, the number one thing I say, before you even secure the satellites, secure your ground stations. So what is the future of LOMIC? Thank you for asking. So it needs updates. I mentioned in my introduction, I told you it's relevant. I mentioned in my introduction that I recently got moved to a purple team. And I have been swamped with work. So I have a whole bunch of updates I need to do to this. The first one is NOS3 released a new version. So NOS3 is actively being maintained by NASA. It's not some old project that came out a long time ago. No, it's being maintained. They have new updates coming all the time. And LOMIC is currently stuck on an old version because I did not think ahead. I just forked NOS3, made edits. I thought, oh, this will be fun, 5-minute project. No, I have hundreds and thousands of edits, and I do not want to try to merge an update of some kind. So I'll have to create a patching system. So anytime a new update comes, it's really simple to get a new version of LOMIC. And we totally need real radio. So I am a ham radio nerd. I have an extra class. I'm on the San Francisco Radio Club. I'm one of the board members there. So we need to get radio working on this thing, and it's super simple. I just have not had the time. Basically, what you do is you take something like a hack RF. You go into GNU Radio, you create a BPSK decoder, essentially, and you can send it raw CCSDS packets over the radio and have it go over to LOMIC, just like a real satellite. And if you are interested in making your own vulnerable satellites, that would be awesome. And let's see. Oh, I mentioned this before. We're using Cosmos 4.5, which is a desktop application. At CCDC, we like web apps. So that will have to be converted to a web app because it's so much easier to get into. Because if you have a desktop app, you have to, RDP in, and you have to have a graphical interface. If you have a web application, you can hack the web application and get in much easier. So we want to do that. It would also be cool to integrate with web mission control software. So if you ever look at a NASA command center, they have all these displays up on the walls with, here's the telemetry from the Mars rover, here's the current camera, here's what's going on. That's mostly open source software. And so we can pipe the data that we're getting back from the telemetry from the satellites, from the virtual satellites, into something like that. And that would be really cool to put on like the main boards. We can see all the teams, all the students. And of course, make it easier to deploy. So I encourage you to check it out. I have the GitHub URLs for both NOS3 and LOMIC. And miraculously, I have LOMIC running right now. So here is LOMIC running in a VM. And as you can see, here's the fake Hubble that does not want to rotate. Oh, it crashed again. I told you this thing's a nightmare. Oh my gosh. Oh, so this is why I had that video. It totally crashed. It ran out of memory or something. Okay, perfect. I'll have to that is amazing. So I will shut this down, see if it even shuts down. We'll try this again in a second. But it worked. Oh my god, this thing is such a nightmare. When it does work, you can send a command. You can turn on the thrusters. You can get telemetry back from it. It just oh my gosh, it totally crashed. Oh, there we go. Well, no, yes, okay. But while we wait for that to boot back up, thank you for attending my talk. Is there any questions? Yes. Yes, it was an attack vector. We tried to get it integrated with the scoring engine. So this is so the question was this an attack vector during the competition? It was. We tried it out. We could not get the scoring engine to work right with it. It will show up again. That's why I told you guys to show up to this, so you know you guys have a head start. You know there's going to be a satellite again, and so we will be ready. We will be ready. It'll be integrated with the scoring engine, and yeah. So yes.
Hi, I wanted to say first off, I'm one of the regional red teamers for Mountain Time Zone, so for the Rocky area. But I wanted to ask, when it comes to implementing the radio on that, I know that you have a license, but is there anything else that you need to go through, like legally, to make sure that that's fine?
Okay, so the question is, so I have a ham radio license. I can legally broadcast. Can anyone do that, or is there some process in place that has to happen? You can broadcast very lightly, as long as you're not disturbing anyone. Everything's legal unless you upset someone, right? Um, but what I would recommend instead is get yourself some coax and some they're not dampeners. What are they called? The not couplers. They reduce the attenuators. Thank you. Words are hard. You get yourself some attenuators, like 80 dB attenuators. Put them on both sides. So you're going to put one on the output from your SDR that's transmitting, and the one that's receiving. And you will not transmit any airwaves, but you can still use it as a radio. And that's actually what we do in labs. Professional labs, we just hook up coax and we get our attenuators, and we can test out radio equipment without upsetting the FCC too much. So, are there any other questions? Yes, yes.
I just wanted to ask, does that work for radar too?
So the question is, does that work for radar? Good question. No. So yeah. So radar is a very difficult subject. um, it does require bounce back. Now, in any coax, you will receive some amount of feedback. So you're never gonna have a perfect transmission, and so you can determine the length of a coax reading the return signal if you have a really good oscilloscope, or an SDR will work. So that's kind of radar. So you can totally do that. But as far as like, scanning the room or something like that, like with radar, like yes. Oh yes, yes, absolutely. Uh, URLs are backup. If you just Google GitHub NOS3-LOMIC, you can probably find that faster than trying to type out that entire URL. And of course, NOS3. Like I said, I'm sure most of you will want to build your own, because it is a great project to learn about spacecraft and how it works, how modern components work, and how they work together. So, LOMIC is a lot of fun, and that's going to be worked on, and we'll have it again for next year, students. um, but if you are looking to get more into space cybersecurity, I highly recommend ignore me. Forget anything I did. Go onto NASA's NOS3, download that, and start playing around with it and making your own spacecraft and have fun. Yes, a mysterious stranger.
Have all those Docker containers. Does that represent like the real hardware systems that would be on a spacecraft, or are they actually Docker containers on a spacecraft?
Okay, so the question was, I had all those Docker containers. Would they be like Docker containers on a spacecraft, or would they be do they represent hardware on the spacecraft virtually? The answer is you would never run Docker on a spacecraft. Never do this. Spacecraft, a few spacecraft, modern spacecraft might run Linux, but it's very bare bones. A lot of them are running what are called real-time operating systems. So they don't even really have a command line. They can't do multiprocessing the way you normally think of. So a real-time operating system is set up so you control the way the processes interact with each other. So if you are firing a thruster and you need it to fire, for example, for exactly 3.7 seconds, you cannot have another process be like, oh, wait, I'm Python. I need to clear the screen for a second. No, you have to have that process have full attention for the full 3.7 seconds. So that's why a lot of spacecraft will run real-time operating systems. And those will not run Docker, whatsoever. So if we look at the Docker container, so we'll start this up again. All right, we'll do a dance and stick our tongue out just the right way, and it should start up again. So we'll go into our workspaces. Yep, there we go. We're going to say make igniter. And there we go. We'll launch it, and you'll see all the windows that pop up once again. So all these are just, oh my gosh, so much stuff. So all of these are basically different Docker containers. So each one of those tabs is a Docker container running a different component that's all connected to the main flight computer. And it's starting up again. Come on, you can do it. You can do it. Oh, it's gonna fail. It's gonna fail. Awesome. Okay. So the graphical interface is not showing up again. That's too bad. But we can, I can show you Cosmos. Okay, so we can go into Cosmos, and you can see here we have the interface for interacting with LOMIC. So here we have the ArduCam. So we have a Arduino camera. By the way, if you think that spacecraft are not running dumb Arduino, Raspberry Pi stuff, you are totally wrong. This is something that irks me to no end. Like, for whatever reason, developers will not use properly space-hardened stuff because this is what they're used to. And so, yes, we can get telemetry back when it works. And we can go down to, let's say we want to look at the telemetry for the cannon, or actually we'll do the thrusters. And we can see here that we received nothing because the graphical interface is not running. But we can, anytime we get to packet back, we can view it, and we can send data out. So we can set, turn on the thrusters and that kind of stuff. But the Docker containers. So if we do Docker PS, you'll see here, oh God, that's a mess. You'll see here that most of these are for each of the components. So you have the radio simulator, the magnetometer simulator, let's see, there's a few other simulators running. The cannon, of course, is running. And then at the bottom, you have a few glue logic type of stuff. So you have Cosmos also running in a Docker container. You have 42, which should be running. It's not because it's a mess. And you have, oh God, so much stuff. You have, let's see, open. So we have, God, why do we have two open seats? This makes no sense. Anyway, that gives you an idea about how messed up this is. So many components, and you cannot, for the life of me, figure out a way to do a good debugging. So if you have a piece of code, so what I want to do as a developer, I want to have my IDE. Like I can use Vim, I can use all the cool hacker stuff, but I want an IDE. I want to be able to click on a line and I want to say, there's a breakpoint, debug. No way this is happening. Not happening here. So, okay. That's the thing that they're doing. Okay. Any other questions? Yes.
So when you said you want to switch over to like web like control, are you planning to switch over to like a newer version of OpenC3 that has all the telemetry and command control on the web UI?
Yes. So the question was, when I move over to the web version, will I be using OpenC3? The answer is yes. I don't know of anything better. If anyone knows a better web interface for commanding satellites, let me know. So one of the things that I noticed is that if you go to the OpenC3 GitHub page, they say that they're no longer supporting the open source version. So if we go to Cosmos, OpenC3, GitHub, there we go. There's a message, yeah, they're saying that 5 is going to be like the last one or something. So that's scary. Yeah, documentation. Maybe not. Maybe I'm imagining things. Okay. I'm hallucinating things. I did not get enough sleep. So ignore me. But yeah, so that's what we'll be doing. We'll essentially just be downloading version 5. Hopefully the settings file, the configurations will carry over from 4.5 to 5, and we'll be in business.